சொல்யூஷன்ஸ்ன்றது ஒரு டூல், நான் யூஸ் பண்ற டூலு டு மோட்டிவேட் யூ பிஃபோர் யூ கோ டு தி எக்ஸாம்ஸ். அவ்வளோதான். இன்னைக்கு நான் கூப்பிட்டது எக்ஸாமினேஷன் பெர்ஸ்பெக்டிவ்காக. ஸோ சொல்யூஷன்ஸை வச்சு அந்த மேஜிக்கை வந்து எப்படி படிக்கணும், எப்படி வந்து அந்த பெர்ஸ்பெக்டிவை கொண்டு வரணும், எப்படி கிளாரிட்டி ஆஃப் தி சப்ஜெக்டை டெவலப் பண்ணணும் அப்படின்றது தான் என்னோட இன்டென்ஷன். இஃப் யூ ஆர் சிட்டிங் இன் திஸ் கிளாஸ், யூ ஷுட் ஃபீல் மேஜிக். ஒரு சப்ஜெக்ட்ல மேஜிக் நடக்கணும், ஒரு ப்ரிப்பரேஷன்ல மேஜிக் நடக்கணும். ஒரு சின்ன சின்ன டெர்மினாலஜி கூட உட்காந்து மாங்கன்னு படிக்கணும். ஒரு சின்ன கம்பேரிசன் கூட சும்மா விட்டுறாம திரும்பி 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 அந்த கம்பேரிசனை நம்ம யோசிச்சுக்கிட்டே இருக்கணும். அப்போதான் மேஜிக் நடக்கும். அதை எக்ஸ்பிளைன் பண்றதுக்கு தான் இந்த கிளாஸ். 10 மார்க்ல கேட்க வேண்டிய கேள்வியை 2 மார்க்ஸ்ல கேட்டாங்க அப்படின்னா ஃபர்ஸ்ட் 2 லைன்ஸ் மட்டும் எழுதிடுவீங்களா? இஃப் a 10 marker is given, okay, if a 10 marker is given, it has to be written in 2 marks. What you do? Once you write 10 marks, you are thinking about there are 4 headings in the 10 marks. There are 4 headings in the 10 marks. Okay? 4 headings which are very crucial topics. Can you understand? Ipo, in how many ways the concentrations can be measured? அப்படினு கேக்குறாங்க நினைச்சுக்கோங்க. How many ways the concentration can be measured ன்னு கேக்குறாங்க. நம்ம கிட்ட எத்தனை ways இருக்கு இப்போதைக்கு? நார்மாலிட்டியை விட்டுருங்க, மொத்தம் 8, including normalities 8. But we have till only molarity 7. Normality வரைக்கும் 8. Normality உங்க டாபிக்ல சிபிஎஸ்சில இல்ல. It is there in NEET and IIT JEE. But leaving normality apart, you have how many? 7 concentrations. These 7 concentrations are asked in 10 marker or in 5 marker. You will write it for 1 page, 2 page, all the concentrations. Am I right? If it is asked in 2 marker, you will write only 2 concentrations? No, you have to mention all the 7. You may not explain every formula, every unit, but you have to write all the 7, even if it is asked in 2 marker. So in that way, if you are having classes for 8 hours, solutions can be done. If you are having class for 2 hours also, solutions can be done, but no topic left. No topic left from the total syllabus. That is most crucial thing that you have to keep it in mind. Sir, I have only 4 hours, sir. Solution chapter can be completed, sir, by myself, by yourself. I mean by myself. Can I do it, sir? Yes, your mindset has to change. How it should be done? Some problems we'll see, some topics we'll see. Whatever is possible till 6 o'clock we'll see. That sample I want to show. I already gave introduction when Sarah madam was taking off. Now only I came to know my teachers will not give me opportunity during the weekdays. At that time, Sarah madam was off on that day. I got an opportunity to enter the class. Am I right? But I was not able to take much. Reason number 1 is you are all new, fresh at that time. Now you saw the subject, right? You are completed till what topic? Colligative. All the 4 are completed. Relative. Elevation of boiling point. Depression of freezing point is not done. Osmotic pressure, reverse osmotic pressure not done. Depression of freezing point itself is an introduction only. There is nothing more in it. One formula, and that formula also the reverse of the elevation of the boiling point. Both are enthalpy. One is endothermic and another is exothermic. Endothermic la aachina boiling point ஏறும். Exothermic ஆச்சுனா boiling point விடுங்க. freezing point போயிருவீங்க. freezing point குறைஞ்சிரும். அவ்வளவுதான். enthalpy change தான். வேற ஒண்ணும் இல்லங்க. புரிஞ்சிக்கிறதுக்கு. osmotic pressure, reverse osmotic pressure என்ன? concentration அதிகமா இருக்கிற இடத்துக்கு solvent போச்சுனா osmotic pressure. pressure கொடுத்து போக விடாம நிறுத்துனீங்கன்னா அது osmotic pressure. இல்லனா அது osmosis. reverse என்ன ஆகும்? concentration கம்மியா இருக்கிற சொல்யூஷன்ல தள்ளுவீங்க. reverse, it is like the reverse of the process. Okay, we will not see that, but I have taken some topics here and there now which will touch everything and which will give you a boost, and untouched areas or Same NCERT lines, you understood in a different way, but how it has to be understood, that will be the concentration. That will be the concentration. Sir, in this, we know that we have 7 types of concentrations. I already know everything, mass component, weight by weight. Okay, 20% of, like, sulfuric acid, like, in 1000 grams of so and so solution, you will have that 20 grams, 200 grams divided by 1000 grams into 100, like that. So this is very easy, and I have given you the best example, best 1 marker or 2 marker ethylene glycol, where that freezing point you told, depression of freezing point, third in colligative properties. Who told me now? Colligative properties la elevation of boiling point சொன்னீங்கல்ல, அப்புறம் என்னன்னு சொன்னீங்க? What did you tell? Next, depression of freezing point, right? What is happening here? Freezing point has depressed or it has gone up. Ethylene glycol you added. How many people read the NCERT once? Lift your hand. This is suicide. Solutions is very tough to handle if you don't have clarity. Same terminology will have a different meaning in solutions. அதே வேப்பர் ப்ரெஷர்னுவான், புரியுதுங்களா? ஸோ சொல்யூபிலிட்டியில் வேப்பர் ப்ரெஷர் வரும்போது எல்லாமே சுச்சுவேஷன்ஸ் மாறும்னுவான். சேச்சுரேட்டட்னுவான், சூப்பர் சேச்சுரேட்டட்னுவான், English is involved. There is nothing called by hearting. Allo alkenes and arenes are what? Just I give it, you vomit it. Give it, vomit it. Do you have any mind there? I don't think. If people who can't remember, organic chemistry is hell. Physical chemistry involves physics and mathematics. Physics and mathematics. People are fear of this. Even in IIT JEE and NEET, physical chemistry has a high weightage. But people don't go there. Reason? Why people are failing in NEET, They are poor in physical chemistry. They are poor in physics. They are good in organic chemistry. They are good in biology. What is the use? By heart. If you understand 50 reactions in organic chemistry, and if you have naming convention clarity, if you have that isomerism and all these properties clarity, hybridization, isomerism, structure, everything, if you have that clarity, polarity, that clarity, and if you have 50 reactions in your hand, all these Woods reaction and everything, if you have Friedrich reaction, etc., 50 reactions in your hand, organic chemistry is over. Not even single time you can tell the same problem. If I change the options, you cannot attend in physical chemistry. Understood? Mass by volume, mass percentage, and volume by volume, mass by volume, parts per million, and also mole fraction, okay, and after that molarity and molality. 7 concentrations you have. 7 concentrations. So what are all those 7 concentrations? How do you handle that? We will go to the problems and then I will teach you there. Through problems I will teach such that you will not have the issue. அங்கேயே நான் உங்களுக்கு பர்சன்டேஜ் கான்சன்ட்ரேஷன்லாம் எக்ஸ்பிளைன் பண்ணிடுறேன், உங்களுக்கு கிளாரிட்டி இருக்கு. This is a brave attempt I am taking on you without explaining you the concept, okay? So what is a solution? You need to understand that. What is a solvent and what is a solute? This information is enough to solve this problem. Solution means the complete setup. Sodium chloride mixed in water. Sodium chloride is solute. Solvent is water. Solvent plus solute is solution. And that solution is binary because it contains 2 components. It contains 2 components. We are dealing with only binary solutions which are having 2 components. Sir, I have solution. What solution contains? Solute and solvent. Best example, NaCl, uppu in water. Okay, and usually solvent is higher amount and solute is lesser amount. One exception you have, if you have 1 kg of salt and 10 ml of water, which is solute, which is solvent? Water is solvent, even though 10 ml does not dissolve the salt completely, even though the 10 ml is not able to dissolve the salt completely, but still the nature of the solvent decides the solvent characteristics. Solvent oda characteristic yaar mudivu pandra? Nature of the solvent. Nature of the solvent is liquid, and that liquid is completely dissolving the solute or not, doesn't matter. What matters is the nature of the solvent. So solute and solvent, here the solvent means whichever is higher in quantity, but here the solvent is not higher in quantity. Am I right? Here the solvent is not higher, but still who is the solvent? Water. Because of its nature. What do you call this? Exception. What do you call this? Exception. Understood? Understood? So now with this knowledge, what is the solute here? NaCl. What is the solvent here? Water. Am I right? Right? So water quantity is how much? 95 grams. And solute is 5 grams. Am I right? They are asking percentage weight by weight concentration. Am I right? Which is nothing but the formula is weight of the or mass of the solute divided by mass of the solution. Mass of the solution into 100, because it is percentage. Can you understand? Sir, solute is how much percentage of the solution? That is the question. உங்களோட percentages பார்த்தீங்கன்னா 8th standard mathematics solutionல solute how much percentage? That is the question. So solute is what? NaCl. So this is what? Solvent. Okay. So you have what? Mass of the weight of the solute evlo? 5 grams, right? And mass of the solution evlo? 5 grams plus 95 grams into 100. This, if you combine both solute and solvent only, you will get what? Mass of the solution. So finally what? 5 by 100 into 100 equal to 5%. So you understand percentage weight by weight concentration is one of the type of concentrations in the 7. மொத்தம் 7 concentration. ஒரு solute ஓட concentration கண்டுபிடிக்கிறதுக்கு this is one of the way. ஓகேவா? NCERT எடுத்து ஓபன் பண்ணும்போது இன்னும் நிறைய புரியும். நான் உங்களுக்கு இன்ட்ரோடக்ஷனோட எடுத்து எக்ஸ்பிளைன் பண்றேன். இப்போதைக்கு என்ன புரியுதோ whatever you can observe, you observe. Okay. Here tell me what is asked? Same question. Same question. Percentage weight by weight is asked. Sir, percentage weight by weight is labeled as 20%. Okay. This percentage is given already. Left hand side is, what is the formula? Percentage weight by weight equal to mass of the solute divided by mass of the solution into 100. Okay. This is given. This is given. So this is given, I put 20 by 100. Am I right? Or you can put 20 if you remove that 100. It's up to you. Okay, I can have 20 by 100, but I have to remove the 100 here. Okay, this is given. What is the mass of sulfuric acid? We don't know. Mass of solute is nothing but H2SO4. We don't know. We don't know. And what is the total solution weight? 250 grams. Am I right? Sir, I am telling you again. Percentage weight by weight concentration means how much solute is present in the solution. How much percentage solute. இப்போ உப்பு இருக்கு 1 liter of solutionல 1 liter of solutionல 200 grams, sorry 1 kg of solutionல 200, ஏன்னா நான் கரெக்ட் பண்ணதுக்கு அர்த்தம் இருக்கு, ஏன்னா அது m/v ஆயிரும், அதனால தான் நான் 1 kg மாத்தினேன். 1 kg of water doesn't matter, it is both 1000 grams and 1000 ml only, it doesn't matter. Water is always density is same and even this is same. So 1 kg solution waterல 200 grams salt is already there inside. 200 grams 1 kg water, no 1 kg of solution, you have 200 grams of NaCl. This 200 gram is inside already mixed. So if I ask you what is the percentage of solute, what you will tell? 20%. What you will tell? 200 gram உப்பு தண்ணியில 1 kg உப்பு தண்ணியில இருக்கு. 200 கிராம் உப்பு 1 kg உப்பு தண்ணியில இருக்கு. அதுல உப்பு எவ்வளவு பர்சன்டேஜ்னு கேட்டா எப்படி சொல்லுவீங்க? 200 கிராம் உப்பு மிக்ஸ் பண்ண தண்ணி 1 kg தண்ணி அப்படி எடுத்துக்கிறத விட நான் இப்படி சொல்றேன், 800 grams water, 200 grams salt, water, salt mixed. How much solution you will get? 1 kg. In this 1 kg, what percentage is salt? What percentage? 20%. இது சொல்ல வைக்கிறதுக்கு எவ்வளவு குட்டுக்கரணம் போட வேண்டியது இருக்கு? This is 8th standard percentage. So if you find, you told 20%, right? You told 20%, right? You have to remove NaCl here, H2SO4 and put NaCl. That is the problem. Percentage concentration of the solute in the solution. Sometimes what they will do is, they will give you the percentage, LHS. Sometimes they will not give you the solute, they will give you the solution. Sometimes they give you the mass of solution, sometimes they will give you mass of solute and tell you to find the percentage. Sometimes they will give you this percentage and mass of the solution, sometimes they will ask you solute. Sometimes they will give you mass of solute, they will give you percentage and they will ask you for only 3 possibilities. One is they will give you percentage, they will give you mass of solute and they will give you mass of solvent, solution. Either they will give you this, or they will give you this, or they will give you this and they will ask you for this. Only 3 combinations. Over. இது ரெண்டுமே கேஜிஸ்ல கிராம்ஸ்ல கொடுத்தா இது 1 கிராம்ல கொடுத்து 1 லிட்டர்ல கொடுத்தா percentage m/v. This is percentage W/W because both are in grams or kg. Am I right? If I put another concentration like percentage m/v, that means solute is in grams, solution is in liquid form or whatever volume, liter. It is in ml or liter. Can you understand? You understood, right? Sir, I have another formula. If you give both in ml format or liquid format or liter format, then I will use what? Percentage V/V. Mass by mass na, you know, 20 grams of sodium chloride in 100 grams of what? Sodium chloride solution. That means how much is the percentage of salt? Means 20%. Am I right? So in the same way, 20 grams of sodium chloride in 100 ml of solution. 20 grams of sodium chloride in 100 ml of solution in the formula m/v. ஏன்னா இது ml ல வரும், ml இல்லனா liter. இது both in 20 ml in 100 ml, 200 ml in 1000 ml, 2 liters in 8 liters. அப்படின்னா ரெண்டுமே லிட்டர்ஸ்லயோ எம்எல்ஏ வந்தா V by V ஃபார்முலா. எதுவுமே மாறாது, பர்சன்டேஜ் சேம். எதுவுமே மாறாது, எல்லாமே பர்சன்டேஜ் சேம். ஒன்னும் இல்ல, you are putting the components where. How do you understand? That is the point. Okay, we'll go to the next thing. Okay, now which is the solvent? Again 15% W by W. Top one is grams and bottom one is also grams. They have given you percentage W by W கொடுத்துட்டாங்க, LHS கொடுத்துட்டாங்க. வேற என்ன கொடுத்தாங்க? மாஸ் ஆஃப் தி சொல்யூட் கொடுத்தாங்களா? சொல்யூஷன் மாஸ் தெரியாது. Mass of solution we know. Do we know? No. And 30 grams is mass of the solute. What to be found? Mass of the solution. So you into 100, right? So you take this, you take this. So finally it is how much? 200 grams of solution. அவ்வளவுதான். Either they will give you this and they will ask you this, or they will give you this and this and they will ask you this. That is the maximum thing they can do. And sometimes you have to do the grams, ml to liter conversion, kg to grams conversion. Do not torture me with that. That is the maximum. That means 4th standard. Now itself we went to 8th standard. So can we go to 4th standard now? No. 1000 grams 10 power 3 and then ml 10 power 3, you convert it to liters. No more torture. You have to understand that much. Conversions are required wherever if you want. It is given in grams. For example, they have given the grams, 30 grams solute they have given, but solution they mentioned in 1 kg. What you will do? What you will do? 10 power 3 you will put, you will bring it both to grams, or you will convert that top one to kg. You will do whatever. Either kg ah paathuvinga illana either grams ah maathuvinga. You have to bring it to uniformity, right? So I don't have to explain that. Next this is also same question. Solve and tell me. Weight by weight எது கொடுத்துட்டாங்க? What is given? Percentage given? Percentage given, 25% is given, right? Mass of the solute given, mass of the solute given, given. And what is our solution is given? Solution is given, mass of the solution is given. இது கொஞ்சம் change இருக்கு. There is a change in this. You have to understand. Sir, mass of solution is equal to mass of solute plus mass of solvent. How many people agree to this? This is NaCl plus water solution. Am I right? So this is nothing but NaCl mass. This is nothing but water. This is 200 grams. This is 800 grams. This is 1 kg. Am I right? Right? So what is given here? Potassium hydroxide. Potassium hydroxide is solute or solute? Potassium hydroxide is mixed in what? Water. Okay. And 25% I have here. Left hand side is clear. What is the mass of the solute? Do you have? Okay. And this solution of KOH weighs 200 grams. Am I right? Solution weighing 200 grams. That means I have solution 200. Am I right? Confusion? Solution, how much it is? 200 grams. So 25% of 200 grams, okay, 25% of 200 grams is what you got solution of KOH, right? Solution. So in 200 grams, KOH percentage is how much? 50? Why? Sir, 25% of 200 grams. This mottham solution oda weight evlo? சரியா? நான் உங்ககிட்ட எக்ஸ்பிளைன் பண்றேன். This is solution and this is the mass of the solute into 100. What you will do? X equal to 50 grams. What is this X? Mass of the solute. Clear? This is nothing but the mass of the solute. And this is what? Mass of the solution. Clarity. I have mass of the solute plus I have the mass of the solution. Mass of the solvent, how do you find? So solution is 200, solute is 50, solvent is y. Solvent is y. Y is equal to 200 minus 50, which is 150 grams of solvent. 150 grams of solvent, which is nothing but water. Yeah, mass of the solvent solution is mass of solute plus solvent. Obviously 200 கிராம் உப்பு 800 கிராம் தண்ணி போட்டீங்கன்னா ஒரு 1000 கிராம் என்ன வரும்? சொல்யூஷன் வரும். கரெக்டா? அதுல உங்களுக்கு 200 கிராம் உப்புன்ட்டாங்க. அப்போ வாட்டர் எவ்வளோ? அந்த 1000 கிராம்ஸ்ல 200 கிராம்ஸ் இஸ் சோடியம் குளோரைடு. வாட்டர் எவ்வளோ? 800 கிராம்ஸ். இந்த ஃபார்முலா தானே இருப்பீங்க. I just want you to copy at least this to understand. Whoever did not understand, whoever understood, leave it. And all these chapters, physical chemistry and also organic chemistry, you will have at least 20 times before you go to the board. Teachers will come and teach. Let them teach. They are contributing from their side. But from my side, I want to make sure that you are doing very well. I enter into 9th standard, 10th standard classes also. It doesn't matter to me. I want 100% clarity to my students. Sir, here I have a different percentage. How does it matter to my life? Nothing. Weight by weight போடுறது பதிலா weight by volume போட்டுட்டு போயிட்டே இருப்போம். How does it matter? What is the formula? What is given? Solute is 10 grams. 100 ml. 100 ml. And what do you have? Percentage. W by V has to be found. And into 100. If you take this as a problem, then what a useless problem. Do you have to stress on this? Nothing. Sir, next. Same weight by weight. Anybody can solve. What is given? Left side is given. Right? Left side is given. And this side, solution is given. What is asked? Mass of solute. Am I right? This equation is right or not? Check. This equation is right or not? Check. Aditya, right? No wrong, right? Ifa, right? Tambi, right? Sai Shweta, நீங்க தான் சொல்லணும். தியா, சாய் ஸ்வேதா, லக்ஷ்மணா, நீங்க தான் வந்து இந்த சாப்டர் பக்கமே எடுத்து பார்த்தது இல்லை. ஆனாலும் ஏதோ ஒன்று புரியுது இல்லம்மா, ஏதோ ஒன்று புரியுது இல்லை, அதுதான் இம்பார்ட்டன்ட். இஃபாக்கு ஏதோ ஒன்று புரிய ஆரம்பிக்குதா? What I promised you is, I started from the middle, but I told you, you will understand something. So, I should put 100, right? Because what will happen if you take this here? It will be 2000, right? Divided by 100. It will be 20 grams. If you don't put 100, what will happen? It will be 2000 grams. Where you will search in the option? Do not ignore even the small things. Sir, this one can be solved. I'll give you 20 seconds. 20 seconds. We have lot to see, sir. We have vapor pressure. We have solubility. We have Henry's law, Raoult's law, ideal solution, non-ideal solution, azeotropic solution, non-azeotropic solutions, colligative properties. What is given? 15 grams of KCl, which is nothing but solute, mass of the solute. Percentage 5 is given. 15 by 5, 5 by 15 is 1 by 3. Am I right? No. 5 into, what will be 5 by? No. 15 by 5. How much it is? 300 ml. Good. This is V by V. How does it matter? I don't have grams. Both are in ml or L. Percentage V by, இது ஒரு டாபிக்னு சொல்லிட்டு தனித்தனியா உங்களோட இன்சைட்டில் எக்ஸ்பிளைன் பண்ணியிருக்காங்க. ஆனா எல்லாமே ஒண்ணுதான். percentage V by V in போட்டா என்ன ஆகும் 25 ml divided by 100 ml which is 1 by 4 into 100 which is 25% concentration which is percentage V by V. ரெண்டுமே ml cancel ஆயிடுச்சு. Over. And sir, now same. I have percentage, I have solution. What is asked? Volume of alcohol. அப்ப mass of solute கண்டுபிடிச்சீங்கல, அது volume of alcohol ன்றீங்க. Mass of solute கண்டுபிடிச்சீங்கல, now what are you telling? Volume of alcohol. So percentage V by V is nothing but 30 is equal to volume of alcohol is asked, which is mass of the solute in the past, and divided by what is given 500 ml solution. Am I right? Into 100. I should not forget. And finally it will be 20 ml volume of alcohol. Over. Any doubts? Next, molarity. You have two problems. Sir, what do you mean by molarity? What do you mean by molality? You would have studied in standard 11. Okay, leave it. If you don't forget, if you would have forget it, it doesn't matter. Sir, molarity is nothing but to understand the number of molecules or number of components or number of moles present in a particular solution. Can you understand? Divided by what? That is what it changes the molality and molarity. I will go to that. And you know this. No, not this. I had a different thing. Can you see this? Number of moles of solute. Anga enna pannom? Mass of solute. Inge mass by mass or volume by volume. Okay, volume and mass by volume, right? We had only what? Mass, volume, adha. சரிங்களா? சொல்யூட்டோட வால்யூம், சொல்யூட்டோட மாஸ் அதான இருந்தது. இப்போ அது என்ன ஆகுது? நம்பர் ஆஃப் மோல்ஸ் ஆஃப், மை காட், திஸ் இஸ் தி ப்ராப்ளம். சார், numerator will be what? I am taking, this was mass in the past, this was volume in the past. What did I change? Moles. I will explain you what is mole. Don't worry. But what did I change? Mass and volume பதிலா என்ன போட்டிருக்கேன்? எங்க கொண்டு வந்திருக்காது? நியூமரேட்டரா டினாமினேட்டரா? சொல்யூட் தானே, சொல்யூஷனா? சொல்யூட். அப்புறம் கீழே என்ன இருந்தது? வால்யூம் ஆர் மாஸ். வாட் டிட் ஐ புட்? வால்யூம். டிட் ஐ சேஞ்ச் எனிதிங் நவ? வால்யூம் தான் ஃபிக்ஸ்டு, மாஸே வராது. அவ்வளவுதான். மாஸ் பை வால்யூம். இதுக்கு முன்னாடி இருந்தது ரெண்டு ஃபார்முலா. என்னென்ன? மாஸ் பை வால்யூம் பர்சன்டேஜ், volume by volume percentage இருந்தது. ரெண்டு இடத்துலயும் வால்யூம் இருந்ததுல. Here also we have volume. That's it. Okay. Anything changed in this except this word? Nothing changed. Except this word, nothing changed in our life. Correcta? அங்க mass of the solute divided by volume of the solution or mass of the solution போட்டீங்க. கரெக்டா? இங்க moles of the solute divided by volume of solution போட்டீங்க. அவ்வளவுதானே? அதுக்கு என்ன பேர் வச்சிருக்கீங்க? மொலாரிட்டி. என்ன, கேபிட்டல் எம் ஸ்மால் எம்? கேபிட்டல் எம். கேபிட்டல் எம் மொலாரிட்டி. கரெக்டா? இப்போ இவனோட கான்செப்ட் என்னன்னா டு பிரிங் காமன் டினாமினேஷன். இப்போ ஃபார் எக்ஸாம்பிள், ஐ எம் யூசிங் யூரோப்பியன் கரன்சி, யூரோ, டாலர், and also like Indian rupee, Pakistani rupee, Sri Lankan rupee, Nepali rupee. In rupee itself, so many confusions. You will ask, what rupee, sir? What everything? So you will bring it to a common metric system. Common metric system, all will be spoken in the form of moles, such that grams to liter, kg to, that conversions will be not there. So every element in periodic table has molar mass, molecular mass, right? Has a molar mass, and every molar mass and which behaves in a different way, and nature of its element is different, and for that every element molar mass is different, and automatically the metric system also changes. Metric system also, because gas component will be measured separate differently. They gas components, noble gases are measured differently, and rare earth metals are measured differently. For example, some are measured in parts per million also. Like if you want to find sodium chloride present in ocean water, you will talk in ppm only, because you are talking about very small quantity with respect to huge amount of solvent. Huge amount of solvent is what? Ocean water. In that, sodium chloride is what? Very less. Even though it is salty, but sodium chloride concentration is what? Very less in ocean water. How do you measure that? Through parts per million. Sir, million molecules of water contains 1 part of sodium chloride. 1 part of sodium chloride will be there in 1 million parts of water. In that way, you are measuring even the smallest quantity using ppm. Okay, that is the 4th concentration. 5th concentration is molarity. Molarity, how do you do it, sir? I will bring everything, gas, water, solid, liquid, it doesn't matter. I talk in moles. For that, what I will do? Sir, I will take the weight of that particular element. Weight of water, I will take. Weight of water, I will take. Weight of whatever, sulfuric acid I will take, or weight of some mercury I will take, and I will divide it with molar mass. ஒரு weight எடுத்துக்கிட்டு, for example, sir, IFA-ஓட மோல்ஸ்ல, IFA-ஓட வேல்யூவை மோல்ஸ்ல சொல்லுங்க சார் அப்படின்னா, IFA-ஓட weight எடுத்துப்பேன், டிவைடட் பை அவங்களோட மாலிகுலர் மாஸ் எடுத்துருப்பேன், அது மோல்ஸ்ல வந்துடும். விஃபாவோட வேல்யூ 20 மோல்ஸ் அப்படின்னா என்ன அர்த்தம்னா, அவங்களோட நார்மல் வெயிட்டும் டிவைடட் பை உள்ள இருக்கிற மாலிகுல்ஸ் எல்லாம் அந்த இண்டிவிஜுவல் மாலிகுலர் மாஸ், அந்த வாட்டிகல் மாஸ் டிவைட் பண்ணா இஃபா 20 மால்ஸ். அதே சாய் ஸ்வேதா அது சொல்லணும்னா, சாய் ஸ்வேதாவோட வெயிட் வேறையா, 10 கிராம்ஸ் ஆஃப் சாய் ஸ்வேதா டிவைடட் பை த ரியல் molar mass of the Sai Shweta will be giving you 18 moles. Can you understand? What I am trying to tell here is, every element has a different molar mass, will give you different moles, but both can be compared. Who is having more number of molecules or much weight means you are 18 and she is 20 and she is heavier than you. But if I talk about molecular mass separately, weight separately, if I tell just the weight of Sai Shweta and just the weight of IFA, I cannot tell really who are much weighter. Can you understand? Who is having much weight, I cannot explain. But when I can explain is, I have a component called A. I have a component called A, I have a component called B. Sir, this is gas and this is solid. Sir, whatever it is, it doesn't matter. What I will take is A oda weight எடுத்துப்பேன், அது கீழே மாலிகுலர் வெயிட் ஆர் மாலிகுலர் மாஸ், உங்களோட அட்டாமிக் மாஸ். என்ன மாஸ்? அட்டாமிக் மாஸ் எடுத்துக்கிட்டு நான் என்ன சொல்லுவேன், அத நம்பர் ஆஃப் மோல்ஸ் ஆஃப் தட் பர்டிகுலர் சப்ஸ்டன்ஸ் A. ஏன் மோல்ஸ் கொண்டு வரேன்? Why I am bringing it to moles? Because there are some problems which tells gas is dissolved in water. Gas is carbon dioxide, water is liquid. This is gas and that is liquid. Totally it's a solution. People will ask you, what is the mole fraction of that particular gas? What is the mole fraction? How do you understand the mole fraction? Abdina, what are they trying to tell? What is the percentage of gas in that water? They are trying to ask that. What is the weight? What is the weight of that gas in that water? இப்போ ஒரு சோடா கொடுக்குறாங்க, I am giving you a soda with Coke, okay, unopened, I am opening it later, unopened soda I am giving you. One question I am asking you, what is the weight of the gas, carbon dioxide inside that bottle? கேஸ்ன்னு பார்த்தா கார்பன் டை ஆக்சைடோட வெயிட் எப்படி, ஐயோ அதோட மெட்ரிக் சிஸ்டம் என்ன, அது எப்படி எடுப்பாங்க, யூ ஹாவ் கன்ஃபியூஷன். வாட்டர்னா லீட்டரில் எடுக்கலாம், எம்எல்ல எடுக்கலாம். கேஸ் எதில் எடுப்பாங்க, கியூபிக் சென்டிமீட்டரா, மெட்ரிக் கியூபிக் சென்டிமீட்டரா, கியூபிக் மெட்ரிக்கா? ஆமாம், ஸ்டாண்டர்ட் டெம்பரேச்சர் ப்ரெஷர் வேற. நான் வரேன். அந்த அம்மாவுக்கு எங்கேயோ ஒன்று தட்டினது அப்படியே 10th 11th பேசிக்ஸ் ஆஃப் கெமிஸ்ட்ரி நல்லா படிச்சிருக்கீங்க ஃபர்ஸ்ட் சாப்டர் லாஸ்ட் இயர், சரிங்களா? அங்கே வரேன் லக்ஷனா, ஒரே ஒரு செகண்ட். அம்மா இங்கே இருக்கம்மா. இப்போ என்னோட பிரச்சனை என்னன்னா, ஒரு கேஸ் ஒரு லிக்விடுக்குள்ள இருக்கு, ஒரு சாலிட் ஒரு லிக்விடுக்குள்ள இருக்கு. இந்த சாலிட் வேற காம்பனன்ட், liquid is வேற component. How do you, they are both dissolved, mixed, you cannot separate it. If you bring that gas, if you bring that liquid, if you bring that solid, if you bring that liquid to common stage, then you can compare. If you don't bring those two components to the common stage, how do you compare? For example, ஆதித்யா இருக்காரு, நானும் இருக்கேன், height comparison வேணும். என்ன வேணும்? இங்க ஒரு மெஷர்மெண்ட் பார் இருந்தா அவர் வருவாரு, நிப்பாரு, 177 சென்டிமீட்டர்னுவாரு. நான் I will come and sit and I will tell I'm 180 centimeter. Can you understand? Both are coming to the same stage. He is solid and I am liquid. That is mole. Half a dozen of mangoes, half a dozen of bananas. Bananas are different. Bananas weight is different. Bananas measurement is different. Bananas taste is different. Bananas nature is different. And mangoes nature is different, weight is different, shape is different. But both are measured in what? Half a dozen. Then you will understand this is half a dozen and that is half a dozen. Now you have a calculation. Both are 6. You will have a calculation to compare. Can you understand? For comparing gas in a liquid, solid in a solution, what do you need? Mole calculation. You have to bring it to, you should appreciate Avogadro for doing this. You should appreciate Avogadro to doing this, for doing this, because without this, you would have gone to hell in chemistry. Sir, I want to mix this much of gas. STP சொன்னீங்களா? At standard temperature and pressure, this much of gas has to be mixed within this water, then only the coke will be happily enjoyed, sir. Means at what pressure and what temperature that has to be sealed. That bottle has to be sealed such that the person when it is opening chilled, he can enjoy that coke, effervescence coke very happily. How much gas has to be mixed, sir? For that you need to know how many moles has to be mixed. Can you understand? So once again, think like mole is also a unit, but it is a common unit. Okay. Number of moles of solute divided by volume of solution in liter. In, it is not ml. Ml story is what? M by M, M by V, V by V. That story is closed. But I am coming to liter, and this one will be okay. Now I go to molality. I change this word, letter, molality. Sir, I go to molality. What did I change? There it was solution, right? Or solvent? Now it is? There it was liter, right? What it is? It looks like what? M by V or no? M by M. It looks like M by M. This is solvent, solvent, solvent. This is kg, kg, kg. If I use capital M, it is liter. If I use capital L, if I use small m, molality, I use kg. And if I use capital M, it is solution. If I use small m, it is solvent. Understood? Clarity? This one is known, but now we will go molarity. Solve this. Sir, what is molarity? What is, once again, what is molarity? Number of moles of solute divided by What? Volume of the solution in what? In liters. Okay. Do you will get 100 into 100 or not? சும்மா போடுவோமே பழக்கமாயிருச்சுல வேணாமா பிரவீனா into 100 will put. Why? We got used to it. Why to avoid? So in this you have to do first this one, problem number 1. After that you have to do this second one. First one என்ன பண்ணுவோம்? First one நம்மளோட பழக்கம் இருக்கு. What is given? 20%. What is that? Mass of H2SO4 divided by, and that is W by W solution. So mass of solution. Am I right? Into 100. So what is the solution? What is the molar mass is given? Molarity is given, and they have given you the density. Okay. Density is equal to mass by volume. What is this mass? Mass of solution and volume of the solution. This is the formula, you know that very well. And we have the volume, we have density. Okay. We have the density, we need to find the volume. Okay. Mass of the solution is how much? Okay. We have, for example, you assume it is 100 grams of solution. Okay. And 20 grams will be what? 20 grams will be what? H2SO4 mass. You can assume like that if you want. Okay. And mass of the solution is nothing but 100 divided by density is what? 1014. Volume is 100 by 1014. And you have the volume. Now what you will do? Molarity solution. This is volume you found. Now you have the moles of the solute. You have to find moles of the solute. Number of moles of the solute. Number of moles of the solute, I will explain you. Number of moles of the solute, how can you find? What you do here? Weight of the solute, which is nothing but 20 gram, and divided by molecular mass is, atomic mass is 98. 20 by 98. So you have this as one thing, you have this as the other thing. Both are substituted in this formula. What you will get? Molarity equal to 20 by 98 divided by 100 by 1014, which is 20 by 98 into 1014 divided by 100. Approximately 5, approximately 10, which is 2 m, 2 moles. This one you will take time, no issue. Who did not understand where? Because I don't want to tell blindly. You give me the task, I will explain it. Very good question. Whenever you have a situation like this, they have given the solution, okay, 20% solution. It can be 10 kg, it can be 20 kg. Out of that 20% is what? H2SO4. So I have assumed it as 100, that's it. It doesn't matter. They told 20% of H2SO4 is present in the solution. Solution, if I take it as 100, it will be 20. Even if I take 200, it will not be a mistake. Even if I take 1000, it will not be a mistake, because it is 20% anyhow. இது 100 grams of solution எடுத்துக்கிட்டு 20% நான் வந்து அஸ்யூம் பண்ணல. இது 1000 grams எடுத்துக்கிட்டு இது 200 grams எடுத்துக்கிட்டா கூட தப்பு இல்ல. As long as the 20% is maintained, still the answer will be, if I understood, I have assumed it to be 200 grams, 100 grams and 20, because it is easy. I can take it as 240 also. I can take it as 360 also. I can take it as 1100 also, 200 also. It doesn't matter. Assumption, right? Assumption. If you want to try, you can try it with 240. Answer will not change. And next question. You will have 3 questions here. Ask it openly. First is over. I want another question. And I want another question. 3 questions. Why we want to copy is to keep the momentum with you. Because next question, the things are going to get complicated in the future. இப்போ மாஸ் பை மாஸ் பார்த்துட்டு வந்தோம்ல, அதுக்கப்புறம் மொலாரிட்டின்னு சொல்லிட்டு வாழ்க்கை காம்ப்ளிகேட் ஆயிடுச்சு, டென்சிட்டிலாம் உள்ள வந்துருச்சு, அசம்ஷன்லாம் வந்துருச்சு, அதுக்கப்புறம் திங்ஸ் வில் கெட் கீப் காம்ப்ளிகேட்டிங். ஸோ ஐ டோன்ட் வாண்ட் யூ டு மிஸ் த பஸ் by leaving the doubts here. Once again, I have assumed here because they have given 20% solution to make my problem convenient. And formula is molality or molarity? Riti. So moles of solute divided by volume of the solution in liters. So for finding the volume of solution in liters, they have given the density. In density, we have given 1014, and mass of the solution is not given. Given. Because we have assumed it. We have assumed it 200 grams, 100 grams. I will put the 100, and volume of solution is, I take it to like that. Density, I took it to this side. So volume I found. So denominator I found. And numerator I have to find. Moles of solute from your 11th standard or your formula is weight of that solute divided by, or mass of the solute divided by the molar mass, which is nothing but the atomic mass. Atomic mass is given in the problem. 98. What is the weight of that mass? I already assumed it. They have given it 20% of the solution. 20% is 20 gram. So 20 gram divided by 98. Okay, that is what you call as number of moles of H2SO4. Number of moles of H2SO4 present in that solution is nothing but 0.2. Is nothing but 1 by 5, 0.2. Totally how many moles? Totally, what is the total molarity? 2 moles. Can you understand? Totally. But 0.2 is number of moles of solute. That means 1.8 is what? Number of moles of solution. No, number of moles of solvent. If I tell something, if you shake your head, you are going to hell. Ama. 5 by 5 தானம்மா, என்னம்மா அது மேல? Number of moles of 20 by 98 is what? Number of moles of solute, right? Number of moles of solute in what? In solution. Number of moles of solute is what? 1 by 5, which is 0.2. 0.2 moles. Am I right? 0.2 moles. That means solute is 0.2 means solution is how much? 1.8, because we have molarity here. Solve this. Not this man. I'm sorry. Solve this. Sometimes I overwork and copy paste 2 times. That is what happened there. For many problems, I took an revision and I have given the step calculations also, because there are some legends in my classes. Sometimes they will ask each step to be copied also. What can I do? At that time, I should have insurance to keep those slides ready. Solved. Over. 20 seconds. I have density. I have urea. Urea oda molar mass. CO NH4 twice. Calculate. இதெல்லாம் படிக்காம இதெல்லாம் மொலாரிட்டிலாம் எக்ஸாம்ல கொடுப்பாங்கன்னு நீங்க போனீங்கன்னா காலை வாரி விட்டுருவாங்க ஒரு வாட்டி. You need this, right, to find molar mass. Number of moles of urea to be found, right or not? Urea oda molar mass evlo? C how much? C how much? Oxygen how much? NH4 how much? Into 2 will put. Nitrogen how much? Next time you are coming to my class, you should know at least 40 molar masses or atomic masses. All popular ones. Top 20 has to be known and 20 other popular ones has to be known. I can come to class at any time. In between any class, you should know all the atomic masses thoroughly. Can you understand? Okay. What is the C evlo? 12. Oxygen evlo? 16. NH4 evlo? 18. 18 into 2, 36. Okay, 36 plus 12 evlo? Gram per liter enna? Malla Ria Lia. Small m capital m? Podu. Density 1.06 ah? Density கொடுத்தாச்சு. Volume கண்டுபிடிக்கணும். 6%. அப்பனா 6% எடுத்தா, for example 1000 grams of water எடுத்தீங்கன்னா 60 grams என்னது? யூரியா. கரெக்டா? 60 grams யூரியா. இப்போ ஃபார் எக்ஸாம்பிள் இப்போ நீங்க என்ன பண்ணணும், டென்சிட்டி எவ்வளோ 1.060 ஈக்குவல் டு மாஸ் ஆஃப் த சொல்யூஷன் எவ்வளோ 1000 கிராம்ஸ் divided by volume equal to 1.060 divided by 1000. So denominator is understood, numerator number of moles of urea, which is nothing but denominator is over, numerator number of moles of urea which is nothing but 64, அதுக்கு மேல 60 right, I assumed it as 60. 100,000 grams எடுத்துக்கிட்டாப்பா 6% எவ்வளோப்பா? அப்பா நான் என்னன்னா 100 எடுத்தா 6 வரும், அது கேவலமா இருக்கும், 60 கொஞ்சம் கெத்தா இருக்கும்னு எடுத்திருக்கேன். புரியுதா? அண்ட் ஆல்சோ ஐ வாண்ட் டு ப்ரூவ் ஏ பாயிண்ட், அது என்ன எடுத்தாலும் ஆன்சர் அதான். புரியுதுங்களா? எடுத்தாலும் ஆன்சர் மாறாதாயி, எப்படி மாறும்? மேலேயும் 100 எடுத்தா 100க்கு 66 போடுவீங்க, 1000 எடுத்தா 60 போடுவீங்க, 1000 அடிச்சிருப்பா, 0 அடிச்சுட்டு போயிடுச்சுல, அப்புறம் என்ன? 60/64 என்னது? நியூமரேட்டர். டினாமினேட்டர் என்னது? இது நியூமரேட்டர் 60/64 divided by denominator 1000. புரியுதா? 60/64 into 1000 by 1.060. இது கேன்சல், இது கேன்சல், 1 ஆன்சர். இவ்வளவுதான். அவன் ஏதோ 1.001 அப்படின்னு ஒன்று கொடுப்பான். அந்த காமெடியில எனக்கு காமெடி தேவையில்ல. 1 இன்னொரு மிஸ்டேக், if I don't put this it is gone. Now you understood why I took 60. It is easy to cancel 64 and 60. You have to see that value and can do it accordingly. Otherwise you have to do like 6, 10, 60, 1/10. Again you have to take that 0 and cancel that. Why that drama? I took it in a convenient way. 1000 ன்னு பார்த்தேன், இங்க 6 ன்னு பார்த்தேன், 60 ன்னு 1000 எடுத்துறேன்ட்டேன், முடிஞ்சு போச்சு. That means you put increase it. How much you put it? It is given in ml, right? See, it is saving me, it is giving me. What will happen? If it is given in ml, the volume, what will happen here? ml la கொடுத்தா என்னமா பண்ணுவீங்க? To bring it in liters, right? liters தானே கீழ இருக்கு. இப்போ என்ன பண்ணிருக்கேன்? divided by 1000 போட்டேன், இது ரெண்டும் காலி. அப்போ இது ரெண்டும் காலி. கரெக்டாமா? இல்ல, கரெக்ட் தான். இன்டூ இப்படி வரும், கரெக்டா? 1000 into 1000 வரும், கரெக்டா? அப்போ மேல போகும்போது 10 power, what she told you understood? It is there in ml. So I have to bring it to liters. Conversion I don't do normally, but still I am doing it. Tell me what should I do here? Conversion, with conversion. I forgot to do the conversion, ma. I did not see that. This is what? 1000, 1.06, right? No. Oh my God, that is the value. 1000 by 1.06. அதுக்கு தான் we should complete the problem and do it. 1.060 divided by 1000 divided by 1.06, right? So you are bringing that here, right? And then what you will do? You will divide this by 1000, right? This both will cancel. So 60/64 will become 1, 1/1 will become, still the answer is 1. Still the answer is 1. Why? அம்மா என்ன நடந்திருக்குன்ற சொல்றேன். I will erase it again. I was given something to assume. 6% of urea solution. So I took like 60 grams of urea in 1000 grams of solution. Am I right? This is what my assumption is. So mass of the solute is 60 grams. Am I right? Now again they have given density. Density is equal to 1.060. Am I right? That was like gram per ml. We know that density is equal to mass by volume. This is mass of the solution, this is the volume of the solution. I know the density 1.060. Am I right? This is 1.060. And mass is how much? Solution 1000. Am I right? 1000 grams. And volume I don't know. So volume to find it, 1000 divided by 1.060. This is the denominator. What is molarity? What is molarity? Number of moles of solute divided by, what is the denominator? Volume of solution. Am I right? Solution, and it will give you M. And so this should be in liters. Am I right? This should be in liters. So number of moles of solute is what? Number of moles of solute is what? I know this is 64. Which one? One second. I know number of moles of solute is nothing but mass of the solute divided by molar mass. Clarity? What is the denominator? 1000 divided by 1.060. But problem is this should be in liters and this is in ml. And this should be in liters. To convert this into liters, what you will do? Sir, I take this and this as 1 only. I take this as 1. I divide that with 1000. Okay? 1000. What happened now? 60 by 64 into Nana. I mean, I multiplied this and I cancelled everything. What I mean, you understood, right? This 1.060 into 1000 multiply panna enna agum? 1060 agum. Idum cancel aichu sonna. Adu purinjudha illaya? 1.060 into 1000 will become 1060. 1060 and 1000 will be approximately divided. And what you will get is 1. Am I right? Into 1, which is nothing but I divided this also approximately and I finally got 1. Only thing is like I hate conversions. I told you at the starting of the class. But still you take care of it. I forgot it sometimes. Conversion பண்ணாம இருந்தேன். ஆனா பாருங்க, கன்வர்ஷன் பண்ணாலும் அந்த 1.060 கவனிக்காம நான் அடிச்சிட்டேன்ல, 1 மோல்னு போட்டேன். ஆன்சர் கரெக்டா போட்டேன். எனக்கே தெரியாம. ஏன்னா 1.060 பார்க்கல. அவ்வளோ ஈஸியா புரிஞ்சுது. Molality. What is the formula? Molality, small m. Number of moles of solute will not change. Number of moles of solute will not change. But number of, what is that? Volume of? Mass of solvent in kg. Solution contains both solvent and solution. So solute and solvent in kg. In kg has to be prepared and solvent has to be properly made. 1 mole of the solute. How much? They have given already mole. No molar mass, no conversion, nothing. They have given you the 1 mole of solute. They have given it very easily. 50 grams of solvent they gave you. What is there to ask here? Nothing. 1 by 50, which is nothing but how much? And you have to convert into kg, right? It is there in grams. So divided by 1000. So 1000 divided by 50, which is nothing but 20 small m. Again density torture came. I will give you 1 minute. Again ml torture is coming there. I will not do conversion. You do the conversion and tell me. Compound என்னன்னே சொல்லலாம். Compound, they did not tell you the compound itself. Density of the solution is 1.12. Mass of the solvent is 1000 grams. Mass of the solute is 120 grams. நான் சீரியஸா ஹிண்ட் கொடுத்துட்டு இருக்கேன் உங்களுக்கு. நான் ஹிண்ட் கொடுத்துட்டு இருக்கேன். Mass of the solvent is 1000 grams. Mass of the solute is 120 grams. Mass of the solution is how much? 1120 grams. Mass of the solvent is water. Mass of the solute is compound. If you combine it, you will get the mass of the solution. You have the mass of the solution, you have the density of the solution. What you can find? Volume? Once you found this volume, what you will try to find? For molarity, what you will try to find? Number of moles of the solute? Chala kashtam deal chestam idu edigani. To understand, to put the number of moles of the solute, we need weight of the solute, which is nothing but 120 divided by 60 molecular mass, which is 2, which is 2 Diya is pumping up. So you got 60 by 120, 60 by, sorry, 120 by 60, 120 by 60, which is nothing but 2 moles divided by how much? 1, which is 2 moles. You got volume as 1 liter. Am I right? Volume as 1 liter. That is the reason 2 by 1, 2 moles. இதுக்கு எதுக்கு பேனா? இதுக்கு எதுக்கு 1 minute time? Now the heavy duty is over. Now I understand some theory. You need a break. Take 5 minutes break. We will come back because now the heavy duty mission will start. For 1 hour you concentrate and I will give you the concepts very clarity. Concepts mattum, vapor pressure, Raoult's law, exceptions, tup, some problem. We'll see something for 1 hour heavily. Forget it. We'll go and study English in the night and write exam tomorrow. Okay? Come on. 5 minutes break. Now I am into theory. We did some problems, right? We cannot keep doing that. So next kuda problems kuduthite ungalku explain pannirkalam. But we'll see some theory where it will be useful for you to write 2 markers and 1 markers and also some 3 markers. Okay? Okay. Sir, I already told you we are dealing with binary solution. Binary solutions means it has 2 components and 1 component and 2 components, right? 2 components. So it can be solute and solvent, or it can be liquid and solid, or it can be liquid and liquid, and or it can be liquid and gas. It can be anything. Adana NCERT starting. So solute and solvent can be either liquid liquid, liquid solid, liquid gas, gas liquid, whatever it is, any combination. But we have only 2 components which can be solvent and solute. Whichever is more practically, which is called as solvent, but less will be solute. Over. I am coming here. Sir, there are solutions containing 2 components, which is liquids and liquids and solids and liquids. Only 2 things we deal in vapor pressure. In Raoult's law also will do the same. In Henry's law will do the same. In ideal non-ideal solutions we do the same. Colligative property also will do the same. What? We'll deal with first objective, liquids and liquids. Sodium chloride in water. Oxygen in water. Gas in liquids. But solids in liquids like sodium chloride or whatever, if you want mercury or if you want to do anything, you can do that. Okay. So we are taking 2 things. Liquid in liquids. So this is a binary solution. Solids and liquids, that is also a binary solution. So first we will take liquid and we will try to understand what is vapor pressure through that liquid solution. இப்போ நம்ம கையில் இருக்கிறது என்ன? சால்வெண்ட்டும் லிக்விடு, சொல்யூட்டும் லிக்விடு. புரியுதுங்களா? இது லிக்விட் சொல்யூஷன். ஓகே, இது லிக்விட் சொல்யூஷன். In this you are telling that you are taking 2 volatile liquids. Volatile na meaning enna? The ability to vaporize easily. Understand very easily. I will repeat this word so many times, don't worry, just listen to my concept. Ability to vaporize easily. That means I will be able to leave the solution part easily and I can go as gas easily. I can leave the solution part very easily and get out of that surface of the liquid and then go as vapor so fast, so easily. I don't have to do any extra work. Volatile. Obviously non-volatile means I will be not able to go so easily like volatile. Okay. Here 2 volatile liquids means what? Solute also volatile and solution solvent also volatile. Solute also volatile, solvent also volatile. Total solution is volatile. I'm coming again. I'm dealing with vapor pressure topic. In vapor pressure, there are two case studies. In vapor pressure, there are two case studies. Case study number 1, liquid mixed in liquid. Liquid solute mixed in liquid solvent. I get liquid solution, which is a binary solution. Case study number 1 is liquid mixed in liquid. Case study number 2, solid mixed in liquid. Liquid is the solvent, solid is the solute, totally it is a solution. Can you understand? Why they took like that, I will explain you in 20 minutes. I will explain you in 20 minutes in more clarity. But I will be explaining you here and there, but more clarity you will understand in 20 minutes. Again, first case study, liquid, liquid. Second case study, solid and liquid. What NCERT is telling is, sir, first case study, liquid and liquid, both are volatile. Liquid is volatile, which is nothing but solute. Another liquid is also volatile, which is nothing but solvent. Solute and solvent both are volatile, so that solution will be volatile, and the ability to vaporize is so easy. Ability to vaporize is so easy. Even if you give little bit of temperature, it will vaporize immediately. It will vaporize immediately. It will vaporize immediately. Understood? Understood. Pressure does not have anything to do here. In both the case studies, pressure does not have anything to do, because we are dealing with solids and liquids. They are already closely packed materials. They are already closely packed materials. Their density is so high, and compared to gas, they are not. Gas is loosely packed material. Gas is loosely packed material. Pressure has significant say in that area. Gas nu vandadhaan na pressure pathiye pesuven. Ana ipo na gas nu edha pesitana. Gas nu edha pesana. Solid, liquid, liquid, liquid. Rendu dhaan case study. Do you have any gas here? If there is no gas here, I don't talk about, like, the pressure component influence inside. But still, what I get from this is a different thing. I will understand. I will make you understand. Again, I am coming. First example, I took solid, liquid and liquid, and I took like both liquid and liquid are volatile. Both liquid and liquid are volatile. And these two volatile things are put in a closed vessel. Where? Put in a closed vessel. And I will tell you what is equilibrium in a moment. Total vapor pressure will be P total, and this is the partial pressure created by the liquid 1, partial pressure created by the liquid 2, and total vapor pressure of the solution will be T. Can you understand? And X1 and X2 are mole fractions. I will make you understand. I will make you understand. You understood the terminology now. Now only we will go inside. We'll go inside. What did I tell before? I will deal with two. What did I tell? I told with two situations. One is liquid in liquid. Next is solid in liquid. You keep this in mind. It will hunt you till the last. And if you don't understand P1 and P2 and everything, you keep it like that. And I want you to jump it, but if I jump, I think you will get confused. Again, I will explain solubility and then I'll come inside. Okay? Okay. And you should understand solubility, which is nothing but the ability of solute getting dissolved in solvent is called as solubility. The capacity of the solute to get mixed with the solvent or getting associated with the solvent easily is called as solubility. That means sodium chloride is able to liquid in liquid. A sodium chloride is ability to completely mix with water. You call it as solubility, 100% solubility. Can you understand? But if you keep mixing the same sodium chloride Beyond a certain level, I told you, 1 kg of salt, put in 100 ml of solution, 100 ml of water. Will it completely get dissolved? Completely dissolve ஆகுமா? ஆகாது. கரெக்டா? அப்போ I call it as super saturated. When you call it as saturated, perfect mix. So 1000 ml of water, 50 grams of salt perfectly gets mixed. Saturated solution. If I add 50 grams more, so if I see the solution, it should be crystal clear. I should not see any crystallization inside. I should not see any precipitates inside. So ஒரு உப்பை எடுத்துட்டு போய் தண்ணியில போட்டாலும் என்ன ஆகணும்? அது கரையணும். மேக்சிமம் அது எவ்வளவு எடுத்துக்குமோ, the ability, the capacity, அப்படிதான் சொன்னேன், the ability, the maximum ability, the maximum capacity, the sodium chloride can be dissolved in particular solution or a solvent is saturated solution. Beyond that level, I cannot take it anymore. I saturated. Tummy is full. I cannot take it anymore. Even if you put inside, it will come outside. Even if you put inside, it will come as outside like vomit. That is called unsaturated. No? Hey, super saturated. You are there somewhere. Listen to me. 3 terms: saturated, unsaturated, super saturated. Sir, this is perfect mixing. And if I add more salt to this, it will not take. No, that is wrong. It will not mix is wrong. Correct. So I have a beaker, I have water, I have put salt inside, and it is completely dissolved and it is reached an equilibrium. It cannot take any more wrong word. It cannot dissolve more correct word. இன்னும் கரையாது அப்படின்றது கரெக்ட், இன்னும் ஏத்துக்காது தப்பு. அது ஏத்துக்கும். It can take, but it cannot dissolve. Beyond saturated level, if you still put salt inside, it will be like super saturated. அதுதான் நான் சொன்னது. 1 kg of water or 1 liter of water mixing, 1 kg of salt mixed in 10 ml of water. This is unsaturated. Super saturated. இப்பதான் தெளிவாறீங்க. Unsaturated means I can take more. I am half tummy full. I can take some more and dissolve. So in 1000 ml of water, I have put only 10 grams of sugar. 10 grams of sugar. That means you can still put more sugar for dissolving it. That means it is unsaturated. It takes some time to become equilibrium, to bring into equilibrium. So again I am coming. Saturated means perfect mixing. It dissolve is over. Dissolution is over. Whatever you put, it will stay as it is. I call it as saturated. What is this stage? I call it as equilibrium. What is supersaturated? Beyond this level, if I put salt more, it cannot dissolve. It will stay as it is, and I call it as supersaturated. What is unsaturated? I have the capacity. My solvent is too much, my solute is little. My solvent is too much, my solute is very little. Still you can give me more what? Solute. I have the ability to dissolve inside. இன்னும் கரையறதுக்கு எனக்கு கெப்பாசிட்டி இருக்குன்னு சொல்றான். எந்த சொல்யூஷன் కరెక్టాன்னு பாருங்க. మునుమే పడిగే టక్ 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 వీళ్ళకి అక్కడికి వెళ్దాం అనుకున్నాను కానీ పని జరిగేటట్లేదు. ఇది చెప్పే వెళ్ళాలి. வேப்பர் ப்ரெஷர் கிட்ட போகிறதுக்கு ட்ரை பண்ணோம்மா, உங்களோட ரிசீவிங் கெப்பாசிட்டி கம்மியாக இருக்குது, மோல் ஃப்ராக்ஷன் எல்லாமே எக்ஸ்பிளைன் பண்ண வேண்டியது இருக்குது. அதனால தான் டக்குன்னு நான் சொல்யூபிலிட்டிக்கு திரும்பி வந்துட்டேன், உங்களோட என்சிஆர்டி ஃப்ளோக்கு வந்துட்டேன். புரியுதா? நான் சொன்னதில் மாறிச்சு ஏதாவது? நான் தான் கிரியேட் பண்ணேன், அதனால் மாறாது. சரிங்களா? ஆமா, இப்போ நான் என்ன சொன்னாங்க, ரெண்டு சிச்சுவேஷன், லிக்விட் இன் லிக்விட், இன்னொன்னு என்ன சொன்னேன், லிக்விட். ரெண்டு சிச்சுவேஷன்ஸ் தான் வில் ஆல்வேஸ் யூஸ். ரெண்டு situations, only with two situations, solid and liquid and liquid. Now which one I am dealing now? Solid and liquid. Okay, இந்த indicator is important. இந்த indicator விட்டுட்டீங்கன்னா, where do we stand என்றது விட்டுட்டீங்கன்னா topic is confusing. Which place we are in? We are in Madurai. First fix that, and then only you roam in Madurai. You will not get lost. Otherwise, the topics within your NCERT will confuse you. Okay, in solubility, we are in which topic? First topic, solid in a liquid. Sir, what is the solid here? Sugar. What is the liquid here? Water. What is the solid here? Naphthalene. What is the liquid here? Sorry, anthracene. Okay, sir, sugar dissolves readily in water, sir. Naphthalene does not dissolve in anthracene, sir. Anthracene, it will not dissolve. Naphthalene and anthracene can dissolve readily in benzene, sir. Naphthalene and anthracene does not mix in water. It has problem. It has that polarity issues and mixing issues. Can you understand? It will not form some. It has different electronegativity. I will explain you in electrochemistry more. Okay, you would have studied in chemical equilibrium, chemical kinetics. Okay, it has different polarity, so I will not accept it. Like poles only can mix with easily. If you have a certain electronegativity, it cannot mix. இந்த மாதிரி மட்டும் நான் வச்சுக்கோங்க. இவனோட சேர மாட்டான்னு நினைச்சு நான் வச்சுக்கோங்க. This person will not mix with this person. Reason is they have a different energy levels. They have different energy levels. Can you understand? Only if you have similar energy levels, they can get mixed. If they have a different energy level, and the dissociation is possible. Can you understand? Okay. Water mix very well with sodium chloride and sugar. Naphthalene and anthracene can mix with benzene very well because they are all polar. They are all carrying same energy levels. Can you understand? Like will mix with like. Can you understand? And if you expect naphthalene and anthracene to mix with water, it will not happen. Again, I am in which topic? Solid and liquid. Benzene is what? Liquid. Anthracene and naphthalene are what? Solid. And coming to sodium chloride and sugar are what? Solid. Which one is liquid? Water. One markers. Please be careful. Sir, this one is over. This one is over. And when a solid solute is added to the solvent, means what? Solvent is what? Liquid. Solid is what? This one. And its concentration increases in the solution. Again, I am coming to that M by M, W by W, M by V, V by V, whatever we have studied, we are coming there only. But we will handle with mole fraction subject. Mole fraction is the only thing which is going to help you in all the other topics. Molarity and molarity has gone to home. No more interest. But which one is more interest now? Mole fraction. So, sir, what I am telling here is, this is known as crystallization and this is known as dissolution. What is dissolution? Mixing it completely. After a certain stage, it cannot take, right? What it will form? That is crystallization. What is dissolution? Mixing. What is crystallization? Coming out. This is going inside, that is coming out. Going inside is dissolution. Coming out is? Going inside is? Coming out is? When you come out? Supersaturated. When you, beyond the saturated point, beyond the equilibrium point, I become crystallized. And beyond the equilibrium, I got what? Crystallization. Before getting supersaturated, till that point I get what? Dissolved. Till that point I get dissolved. After that I get crystallized. Before that I get dissolved. So it is a reversible reaction. What is that? Reversible reaction. Solute and solvent will become solution and solution again will become crystallized. This will dissolve, this will crystallize, dissolve, crystallize, dissolve to make a solution, crystallize to make a solute and solvent. Again dissolve to make a solution and then crystallize to make a solute and solvent. முன்னாடி போயிட்டு sugar will mix with water and form a solution. Again sugar will come out of the solution, solvent. Sugar will come out of the solvent and then crystallize and it will get separated. Again they will get mixed, will go there. To change this process, if you apply temperature, you may change the equilibrium point. After a certain stage, you are reaching a saturated point, right? What is that saturated point? I can't dissolve the solute anymore. I can't dissolve the solid matter anymore. I can't dissolve the sugar anymore. Who is selling this? Solvent. Who is selling this? Solvent. Na innala mudiyaduppa. Na vandu maximum I have dissolved pa. At that time the equilibrium has reached. But if you put heat in the water, you can shift the equilibrium point. And a new equilibrium will be. அது கூட ஒரு டைம் இருக்குல்ல. You are in 293 Kelvin, 273 Kelvin, you are increased to 293, some new equilibrium will come. The solubility inside increases. What will increase? Solubility increase ஆகுதுன்னா என்ன? Dissolving is increasing. That more amount of sugar is mixing in solvent. But that temperature also has a limit. After a certain point, it will become saturated. That is the new saturated point. So, before at 273 Kelvin, I have reached this level. That is saturated point. Beyond this, I cannot mix. Who is telling that? Solvent. Beyond this, இதுக்கு மேல நான் வந்து mix பண்ண முடியாதுன்னு சொல்றான் ஒருத்தன். யாரு? Solvent. கரெக்டா? அந்த பாயிண்ட மாத்தலாம். உன்னால மிக்ஸ் பண்ண முடியும், சூடு ஏத்தலாம் முடியும் அப்படின்னு சொல்லி இந்த லெவலுக்கு சேச்சுரேஷன் பாயிண்ட் இன்க்ரீஸ் பண்றான். ஆனா டெம்பரேச்சர் கொடுக்குறான். என்ன கொடுக்குறான்? டெம்பரேச்சர் கொடுக்குறான். இதுதான் லேட்சியத்திலே சொன்னான். சரிங்களா? இன்னொரு அட்டெம்ப்ட். போலார் சால்வெண்ட்ஸ் which are water, methanol, ethanol, acetonitrile, isopropanol, and non-polar are chloroform, toluene, hexane, dichloromethane. So, and polar, again I am telling you, and again I am telling you, they have electrical poles and they do not have electrical poles. That is the reason these guys will mix with themselves. These guys have mixed with themselves. Electronegativity difference. I'll go to that later. And come here. This is what reaction? Reversible reaction. What is that? Dissolution, crystallization. The concentration of solute will remain constant under the given condition. Temperature and pressure are same. Can you understand? So, but when gases are dissolved, who is going to read this? Please read this. When the gases are dissolved in liquid solvents, same temperature and pressure is called a saturation. Means what? I am talking about a topic called solid in liquids. In this is possible, right? And now I am talking about a topic called gas in liquids, and that is possible also. But at what temperature and pressure? It matters. Topic is solid in liquids. Topic is not saturated, non-saturated, unsaturated, supersaturated. Topic is not that. What is the topic? I am talking about solids getting mixed in liquids. It gets easily mixed, which is called dissolved, which does not get mixed after a certain point, crystallized. Over. But at what time? At what condition? Temperature and pressure. And will remain constant. That means equilibrium will not change. But if you remove solid and put gas there, if you remove solid and put gas there. I means what? I removed the solid and puts gas there. If you change the temperature, the game changes. Before what I told, no, even for the liquid, if you increase the temperature, equilibrium changes, but that is negligible. But which is remarkable? Gas and liquids. Gas in liquids. There also change can be observed, but it is very less. But here you can see immediately, because gases are loosely packed materials. If you put temperature and pressure in liquid also, it is closely packed materials. You cannot create change. You cannot create change. It will little bit only it will improve, but it is negligible. But which one is more important? Gas and liquids. So our topic literally changed from solids and liquids to gas and liquids. Reason number one, solids are closely packed material. Density is high. Even if you change the temperature and pressure, you cannot change the saturated point. You cannot change the equilibrium point. Dynamic equilibrium cannot be reached so easily. If you change it, you cannot shift to the dynamic equilibrium. But if you are using loosely packed material, if you put pressure, if you put change temperature and everything, what will happen? Equilibrium point can be changed and solubility can be changed. Can you understand? There also can be changed, but it is very less. But here you can measure it. So now you study this. Now if you don't understand, I will come to read this paragraph. Why I was resisting the topic heading, you understood? I am in solid and liquid, but I am transferring my knowledge. I am just slowly transiting to gas and liquids. When I am in solid and liquids, it doesn't matter. Saturated, supersaturated, all are fixed. Equilibrium is fixed. Even if you increase the temperature, solubility will increase, but you cannot measure it, because they are all closely packed material. To break the bond and then become dissolved is impossible. Can you understand? Now come to the point. But if you put gas there, if you change the temperature, if you change the pressure, some changes you can observe. In what? Solubility. In what? Solubility. What is that solubility? How can you measure? In mole fractions. How can you measure? Mole fraction. So, I want to understand, now I am coming. I am oxygen, I dissolved in water. I am oxygen, I got dissolved in water. It is very less. Oxygen in water is very less. Very less. In big ocean, you have oxygen inside. Animals are species, aquatic species are living there. Am I right? But if you take that oxygen, is very less. How do you do this? What I will do is to find the oxygen levels and everything. Sir, I will totally calculate the solution number of moles, and then I will see what is the number of moles of solvent, and then I will see the number of moles of solute, which is oxygen, and finally I come to a conclusion, which is mole fraction of the solute. Means what? Leaving the, for example, number of moles are, I told you this, in one area, 0.2 is this one. If you minus from 2, what you will get? I asked you. 1.8 you told. Same thing. That is what you call as mole fraction. Sir, totally I have 2 moles of solution and 1.8 moles of solvent. Then what is the mole fraction of the, solute? 0.2. But coming to the concept like probability, in mole fraction there is a concept called as, if you add all the mole fractions of the solution, all the components, it will become 1. So like a percentage. Where is then my concentration of solute in such a solution is, when you increase the concentration, when the solute is increased, when the solute is mixed in the solvent, properly. When you can do that properly? When you change the temperature and pressure. எழுதிருக்கான் பாருங்க, temperature and pressure also control this phenomenon. Normally they get mixed, but beyond that point if you want to mix, what do you need? Special support from. First is temperature and pressure. Again, where I am? Solid in a liquid. Solid and liquid I already explained you. Temperature has something to do, but pressure has nothing to do, because you need gas for pressure. I told you it is not significant change like gas, but there will be some change in solid and liquid. Solid and liquid la நம்ம already சொல்லிட்டேன். Solid mixed in liquid, temperature if you put, what will happen? Solubility increases. Can you understand? But pressure has nothing to do here, because nothing is gas here. And what is the second situation? Gas in a liquid. Here temperature and pressure has something to do. There only temperature works, not pressure. But here temperature and pressure. So hydrochloride as gas is highly soluble in water. Okay. And again, now anything has to be okay. This one, I told you, new equilibrium will be created, right? If you increase the temperature, if you increase the pressure, beyond that saturated point, some other new saturation point will come. Am I right? That is explained here. Please study and explain. Ask me. நான் சொன்னேன், temperature increase பண்ணா, pressure increase பண்ணா, gas and liquidல புது equilibrium point வரும்னு சொன்னேன். புது equilibrium point என்ன? புது saturated point. New saturated point. Before it was saturated, it cannot dissolve gas anymore into the liquid. Am I right? Gas is solute. Solvent எது? Water. Water gas வந்து solventல mix ஆயிருச்சு. ஒரு particular pointக்கு மேல அது mix ஆக முடியாது. அது பேர் என்னன்னு சொல்றோம் நம்ம? Saturated solution. Am I right? But if you want to increase the gas content inside the solvent, gas oda concentration நம்ம increase பண்ணனும்னு நினைக்கிறோம். gas oda concentration நம்ம increase பண்ணனும்னு நினைக்கிறோம். எதுக்குள்ள? சொல்யூஷன்ல. Am I right? பண்ணும்போது அங்க நம்ம என்ன பண்ணியாகணும்? pressure கொடுக்கணும் plus temperature. But pressure has more to do. இப்போ கோக்ல அந்த வாட்டருக்குள்ள கார்பனேட்டடா இருக்கணும்னா ஒரு சர்டன் பிரஷர்ல தான் அந்த மூடியை க்ளோஸ் பண்ணுவாங்க. சோடா தயாரிக்கிறதெல்லாம் பாத்தீங்கன்னா நீங்க வச்சு வந்து ரொம்ப பிரஷர்ல தான் அதை வந்து க்ளோஸ் பண்ணுவாங்க. புரியுதுங்களா? அந்த பாட்டில் அடிக்கும் போது அந்த பிரஷர் தான் ஃபர்ஸ்ட் வெளியே வரும். அந்த சர்டன் பிரஷர்ல வச்சாதான் அந்த லிக்விட்ல அந்த கேஸ் தங்கும். Otherwise, if you leave the soda just like that, what will happen? In 10 minutes, all the gas inside which was put under certain pressure will be going out, and that will become like a normal tonic water. Gas இல்லாம கோக் கேவலமா இருக்கும். பார்த்திருக்கீங்களா என்னைக்காவது? சோ அது ஏன்னா அந்த பிரஷர்ல தான் அது solubility அதிகமா இருக்கும். If you remove the pressure, the solubility of the gas within the liquid will be gone. இப்போ கேம் என்ன? solid in liquid and gas in liquid. அதான கேம். நம்ம என்ன புரிஞ்சுக்கிட்டோம்? solid in liquidல and gas in liquidல what did we understand? Sir, there is a saturated point, sir. If you give temperature, this saturated point may shift, sir. That I call it as dynamic equilibrium, sir. There is a reversible reaction, sir. Dissolution, sir, crystallization, sir. Dissolution, sir, crystallization, sir. You can change it to with the temperature, sir. If increase in, but there is no pressure works here, sir. With pressure it will not work because it is closely packed material, sir. Okay. What is gas in liquid, sir? Gas in liquid, sir, amount of gas put in the liquid will be also saturated, sir. At what point, sir? Will be saturated. But we call it as condensation here, not crystallization. அங்க என்ன சொன்னோம்? Dissolution, crystallization. No. இங்க dissolution and condensation, because it is vapor formல இருந்து திரும்பி liquid formக்கு மாறும்போது என்ன சொல்லுவீங்க? அத condensation. So dissolution, condensation will happen, sir, at saturated point, sir. But if you want to change the saturated point, sir, what you have to do, sir? You have to put more pressure, sir. You have to put more pressure, sir. Sir, if you want to put more pressure, the temperature has to be low, sir. More the temperature, sir, less the pressure, sir. Less the temperature, sir, more pressure. More the temperature, sir, less the pressure. So, gas in liquid is what? I have dissolution and also condensation, and also I have what? Temperature should be less and pressure should be more, and if you have pressure more and temperature less, the solubility increases. Which solubility? Gas in liquid will be increases, and this, after this increase, you will have a new equilibrium point. You will have a new equilibrium point. New equilibrium point is nothing but new saturated. If you still want to increase the solubility, put more pressure, reduce the temperature. You enjoy Coke in chilled. You take the same Coke and put it in sun for 2 days. Put it in sun for 2 days. Even if the cap is not removed, you will not enjoy it. The pressure will be automatically reduced. That is the reason the Coke is served chilled. If you put it in a freezer or a refrigerator, the pressure inside will be sustained. Once you open it with the effervescence, if you drink, you will feel happy. But the same Coke is put in a hot environment and drinking it, I don't think you will be enjoying it. இப்போ இதுக்கே தொங்கிட்டீங்களேப்பா, இழுக்கல உங்களுக்கு. I can see that you have reached a super saturated point. And only because I am shouting and repeating the same content and again, you are able to concentrate. Otherwise, the receiving capacity, that means I am literally putting pressure on you to increase the absorbing capacity, like increasing the solubility. What is that pressure? Repeating the content again and again on you. Who did not understand this line? If you have understood that, you understand. So, I will give you this definition and then I will send you home. Sir, Henry has given a quantitative relation between, sir, this is the gas particles, they are loosely packed, this is liquid, they are densely packed, and these gas particles are separately there. If you put too many pistons on the top, you are putting pressure and you are making the gas particles to condense, like you come closer and then puts a pressure on the surface of the liquid and tries to get it inside. Try to get inside, and solution also automatically, number of moles of gas within the solution is increasing. Can you understand what I am telling? Number of moles of gas within the solution is increasing. Solvent and solute are getting mixed. Can you understand? So I take this like this. Before this, mole fraction means number of fraction of the moles, like the percentage of, like that, percentage of gas in solution is less here. Gas oda percentage idukulla kammi. Ana if you put pressure, these gas particles will enter inside and the percentage of gas in solution is more. That percentage is mole fraction. Before it was like here the gas is 0.1, solution is 0.9. Now what will happen? Solution la water, the percentage I am talking about, 1%, for example, 10% gas and 90% solution. Like, can you understand? 90%. This is the portion. Now what will happen? Like, 30% and 70%. Sir, it doesn't mean that solvent has become less. Solvent volume increased. Volume increased. Overall, volume increase ஆச்சு. ஆனா அதனால வந்து சால்வெட்டோட குவாண்டிட்டி did not reduce. Percentage of gas increased. அவ்வளவுதான். புரியுதுங்களா? Percentage of gas. That I call it as mole fraction. Mole fraction. So what they are telling is, I am talking about gas in liquid or solid in liquid? Gas in liquid. So I don't first லேந்தே அதை புடிச்சிட்டு வரேன்னா, இங்க வந்து டெஃபினிஷன் கிட்ட நான் அதை புடிச்சிருந்தா you would have understood. From the first itself I am catching that word. I am not in a solid in a liquid. I am in gas in a liquid. Is directly proportional to solubility, is directly proportional to okay, partial, that is nothing but this one. Okay, partial pressure of the gas present above the surface of the solution. That means, sir, whatever the pressure I am getting from here is nothing but the amount of pressure present here. In the pressure da inge podudhu. So if I can understand how much pressure is available here, then I can understand how much pressure I am putting on the liquid. Okay, so soluble. If you increase the pressure of this, this gas will go inside or not? If I put more pressure here, the gas will go inside or not? If the gas goes inside, means I am increasing the solubility or not? I am increasing the concentration of the gas or not? I am putting more carbon dioxide into water or not? If I am putting more oxygen in water or not? That means if I don't put pressure on the gas here, can I go inside? No. I have to put the pressure on the gas to make it go inside. Am I right? That means partially gas is here, partially gas is inside. This partial gas pressure putting on the liquid is nothing, will increase the solubility. I will writing in a different way. Partial pressure above the liquid, am I right? Is if you increase, okay, partial pressure above the liquid, if you increase, solubility or dissolution increases. Partial pressure above liquid is this one, I increase, okay, and solubility inside this, I can put a gas more, it increases. Okay, now you study this. By heart பண்ணவே கூடாது. Solubility increases when? Above the surface of the liquid is increased. Above the surface of the liquid, if I increase it, more amount of gas will go into the solution and automatically the solubility increases. It will reach a new equilibrium point. It will reach a new saturated point. It will reach a new equilibrium point. Can you understand? I put more pressure above the surface of the liquid. It will increase what? Saturated point. It will create a new saturated point. With what? New solubility. More amount of gas is mixed in the solution. With what? Partial pressure applied on the surface of the liquid. Why I call it as partial pressure on the top? Because some of the gas is inside the liquid already. Only few gas particles are above the surface of the liquid. Can you understand? I call this as Henry law. And this is the partial, this is the solubility, this is the mole fraction, this is the Henry's constant. So if I want to increase the solubility, I increase the pressure of the gas going inside. And what is that gas? Is mole fraction. What is that mole fraction? Total amount of gas particles and only taking the fraction of the gas particles above the surface of the liquid. அந்த மட்டும் எடுத்தா அது mole fraction. If you take the total moles, which is inside and outside is total moles of the gas, which is only available. Surface of the liquid மேல மட்டும் இருக்கிறது மட்டும் எடுத்தா அது mole fraction. Fraction of the moles. Fraction of the moles. இப்போ total moles 100 ன்னு நினைச்சுக்கோங்க. 20 inside, 80 outside. Mole fraction எடுத்தா என்ன வரும்? 80. If I put pressure on 80, in this 80, 30 will go inside the liquid. And how much is left on the top? 50. How much is mixed in inside? 30. 30 plus 20, 50 inside. So I will calculate this and I will tell you. This is the closed container. This is the gas. Okay, this is the gas. And this is the liquid part. Okay, this is the liquid part. Sir, I have totally 20 gas particles here, 80 here. I put pressure here, sir. And out of this 80, 30 go inside. 20 plus 30 gas. Here it will be 50. What happened? The mole fraction. So total gas is 100. Out of that 80 was on the top, 20 is inside. Can you understand? Now I put pressure and some moles are going inside the liquid. Some moles are still staying outside. How do I calculate that mole fraction? Is different formula, don't worry. That is so. If I want to increase the solubility, I will increase the mole fraction. If I increase the mole fraction, I will increase the solubility. That means that I put more amount of gas particles here, I get more pressure. I get less amount of gas particles here, less solubility. More amount of gas particles, more solubility. Less amount of gas particles, less solubility. Over. Okay, I have given you the introduction, but we will see. Sometime, I don't know when I will get this opportunity, but over the period of time, I will complete it. Not only this, next will be electrochemistry, and next will be like, it will keep on going like this. When I will complete this, when I will happening this, we'll see. Some are getting introduction, some are getting this. These classes are conducted once in a while. I'll make it more, but I want you to contribute little bit. I want you to read once physical chemistry, any part, before coming to that. If you have exams, I don't want you to take time. But if you don't have exams, if you have nothing to do, I want you to read once, if you understand or does not understand. But I am promising you, if you open the book now, NCERT, you will understand better. Because the terms we played very well. Terminology we played very well. I think you don't have exams now. You can read once. Praveena, you have exam, you have exam. You three can read once. Aditya have exam, you can also read once. Read it. I am not telling to study. Read it. Once you read it, we'll see. I want you to solve at least couple of problems in Raoult's law and ideal solutions, but unfortunately, and mole fraction also. But unfortunately, we are exceeding time. So we cannot go beyond this because they have English exam tomorrow. So we'll stop here and we'll see. I took that chance to solve the problems of Raoult's law directly at 5:30. But once I saw your faces, okay, solubility itself is not there in the mind. No, so I changed my mind and I came back to solubility. But I never thought 2 concepts in solubility will take 1 hour. Okay, thank you.